Welcome to The Explainer. Today, we're going to zero in on just one bone, but what a story it tells about an animal's life, its movement, and even its evolution. We're talking about the scapula, which you probably know as the shoulder blade. So, let's kick things off with a bit of a clinical mystery. You may have seen or heard of this strange condition where a horse's shoulder muscles just seem to waste away, making the bone underneath stick out like crazy. We're going to find out exactly why that happens by the end of this explainer. All right, here's the game plan. We're going to start with the basics of the shoulder blade, then learn its key landmarks. After that, we'll get into a species showdown to see how it differs between animals, connect it all back to a real-world clinical case, and finally, we'll test your new anatomy IQ. First things first, we need to get our bearings. Where exactly is the scapula, and what's its main job? Okay, take a look at this horse skeleton right here. See that big, flat, kind of triangular bone up top? That's our guy, the scapula. It sits right up against the side of the rib cage and basically forms the entire foundation of the shoulder. Now, here's something that's really key to get. You and I, we have a collarbone, a clavicle, right? It braces our shoulder. Well, most of our domestic animal friends don't. They're relying pretty much solely on the scapula and a whole sling of muscles to attach their entire front leg to their body. That makes it absolutely critical for everything from walking to running. Okay, so now we're going to zoom in and get into the nitty-gritty. Every single scapula, doesn't matter the species, has some common features, and you've got to get a handle on these before we can start spotting the differences. And you know what I love about this image is that it shows you the universal language of the scapula. You've got that big, prominent spine running down one side, these depressions called fossa where muscles sit, and then down at the bottom, that socket, the glenoid cavity that forms the shoulder joint. So these are the landmarks you've got to know. And those fossae, pay close attention to them. They're like little pockets where these super powerful muscles, the supraspinatus-infraspinatus, live. And those muscles are doing the crucial job of keeping that very mobile shoulder joint stable. Okay, now for the fun part. This is where things get really interesting. How does this basic blueprint get tweaked when you're looking at a horse versus a dog or an ox? Let's put them side by side. So first up, let's talk about something called the acromion. It's that little bony bit at the very bottom end of the scapular spine. And believe it or not, whether it's there or not is a huge clue when you're trying to figure out what animal you're looking at. And this chart just lays it out so clearly. Look at this. The horse and pig? Basically no acromion to speak of. It's just not there. But for the ox and the dog, yep, it's present and accounted for. And here you can see it plain as day. Check out that bony projection at the end of the spine on both the dog and the sheep. It might look small, but it's a really important attachment point for the deltoideus muscle, which helps them flex their shoulder. All right, next up, let's look at the spine itself, because it's not just about what's at the very end of it. Where it's positioned actually tells us a ton about the muscles on either side of it. So what does this all mean? Well, think of it like muscle real estate. On a horse, that infraspinatus muscle gets a huge chunk of space, about 2/3 of the whole surface. But on a dog, that spine splits things pretty much 50-50, right down the middle, which tells us those two muscles are much more balanced in size. Okay, our last big comparison point is a tiny little detail, but trust me, it's a huge giveaway. It's a small little indentation on the rim of the shoulder socket called the glenoid notch. So here's the deal, and this is a great little tip for you. If you ever pick up a scapula and you see a clear, distinct notch on the edge of that socket, you can be almost positive you're looking at a horse. It's a total hallmark feature. For the others, it's just not there. Okay, so you might be thinking, why do we need to know all these bumps and grooves? Well, it's because this stuff matters in the real world. This kind of anatomical knowledge is absolutely vital for veterinarians. Remember that mystery we started with? The horse's shoulder that looked like it was wasting away? Well, let's solve it. The condition is called Sweeney, and the cause is tied directly to the anatomy we've just been talking about. So here's what happens. There's this nerve, this supraspinatus nerve, and it has to wrap really tightly around the front edge of the scapula to get to those muscles we talked about. Now, imagine a horse from back in the day pulling a heavy wagon with a collar that just doesn't fit right. That collar presses and presses right on that spot and damages the nerve. When the nerve is damaged, the muscles it controls start to waste away. And that's when you see the spine of the scapula become so visible and the shoulder gets unstable. All right, you've learned the basics, the key differences, and why it all matters. You ready to put that new anatomy IQ to the test? Let's do it.
Okay, take a close look at this one. The big clue is at the bottom of the spine. See how there's, well, nothing there? No extra process sticking out? So is it an ox, a dog, or a horse? If you said horse, you got it. That missing acromion is the dead giveaway.
All right, how about this one? I want you to notice two things here. First, there's definitely an acromion process at the end of the spine. Second, look at how that spine just about splits the whole thing in half. So with those two clues, a clear acromion and that spine right down the middle, is it a horse, ox, or dog? It has to be the dog. See? You're reading these bones like a pro.
So when you really think about it, how amazing is that? The unique shape of just one single bone can tell us so much about how an animal evolved, how it moves, and even its history with us humans. It just goes to show you anatomy isn't just about memorizing parts. It's about learning to read the incredible stories written in bone. Thanks for joining this explainer.